Welcome to the 2020 Earth Science Week webinar series, Earth Material Frontiers. This series is being hosted by the American Geosciences Institute, the Mineralogical Society of America, and the International Raw Materials Observatory. We would also like to thank the sponsors of this webinar series, the International Union of Geological Sciences, Resourcing Future Generations, and the Irish Centre for Research in Applied Geosciences. It is my pleasure to introduce Norbert Jajan of the University of Miskolc, who will be speaking to us today about the need and solutions for robots and responsible raw material exploration and mining.
Everybody, my name is Norbert Zajzon. I'm from the University of Miskolc, from Hungary. And I'd like to thank the possibility to invite me to the Earth Science Week, where I can introduce a bunch of nice robotic projects I was involved. Before I start the talk, I'd like to give a short overview what I'd like to present today, and to able to see the benefit and understand the project. It's always better to see a bigger picture. So for example, if we'd like to understand the different geological processes in the earth, it's much better if we examine it in the context of our solar system, because we will understand much more in detail the ongoing processes. So according to that, I'd like to introduce a bit of raw materials, the raw material demand, and what the European Union, how the European Union try to supply its demand, including the list of critical raw materials, and why these robotic projects are generated as a response of the raw material need. After that, I will present 5 projects which I was involved in the raw material exploitation. I was involved in more, but it's a nice selection which can be represented today. And let's see what will be them. They will be these projects will be UNEXMIN, UNEXUP, the VAMOS, the RoboMiners, and the CHPM 2030. The structure, at first I will present a short video about the project, and in few slides I will comment them further. But let's see why we need raw materials. Where the things are coming from around us in the society. Just think about cars, mobile phones, or clothes, or bags, what you are using. But if you think about not just your personal items, the buildings, the roads, the bridges, the different infrastructure like pipelines, the electrical grid, and so on. Where are these coming from? Where they are made of? Of course, if you take a look for the periodic system, everything is built up by different elements of the periodic system, usually up to the uranium, and really only few of these elements are not mined from solid rocks from the earth. Just really few gases like oxygen or the noble gases are taken out from the atmosphere, but usually all the elements are mined. So to build a house, to have a cell phone, we need these elements, and of course we need mining. But how it's changed with the history. In olden area, you just think back to the Stone Age, we needed only one raw materials, which was a good quality stone to create a stone axis. And with the development of the humankind, with the Bronze Age, Iron Age, we started to utilize few elements. But if we take a look in the energy, in our energy production, even in the last couple of 100 years, you can see we used only few elements in the beginning, and with the industrial revolution we started to use more and more complex technologies to create energy, which needed a lot of elements. And nowadays, with the so-called green technology, with the solar cells, wind turbines, we use the majority of the periodic system. So the variety is growing, and how much we need. This is a bit older data, but roughly can represent what a human person needs in their life, including in developed countries. We need a lot of construction minerals. We construct building like building stones, gravel, cement, and so on, and also a lot of ores we we need. But how much is it, and is it enough? If we take a global raw material extraction, we see in long term it's a continuously growing process. If we just select the ores and industrial minerals or the construction minerals, and this trend, it's not just going for today, but this is our predictions for the future, especially if we like to change our society for a much reliable way. For example, going to an electric vehicle business, we'd like to increase the electric vehicles in Europe, of course, for meet the CO2 demand and all the environmental aspects. But this will need a lot of battery materials, a lot of elements, lithium, graphite, cobalt, uh, which even more and more which we use nowadays. And these elements are produced in really few countries, especially in China, which could be a problematic question. But what about the other green technologies like wind turbines? There is an assessment with what kind of elements we need, and bunch of them are considered critical raw materials. If we look other high tech segments of the industry, for example the defense industry, you will see a lot of raw material is needed, and bunch of them, or the majority of them, are in the critical raw materials. But what are these critical raw materials mean for Europe? Where the humankind mined in history? In the medieval ages and even the early New Age, mining was done mostly in Europe, and in the middle of the 20th century, uh, this was in the US, and nowadays the rest of the world, and really few percentage of primary raw material mining is going on, for example, in Europe nowadays. And this creates a supply risk, supply problem, which is already existing or can exist in future more, because 95% of the raw materials of the European Union is imported. And if it's controlled by an unreliable country and only one country, it can create a problem. Just think about the rare earth embargo of China, what kind of influence it had when in 2008 stopped the rare earth element export uh, from China. Of course, The mining can answer these embargoes and restrictions, but mining is a very slow process. If you start an exploration and development of a mine, if the first bullion of metal coming out from the production, it's generally 10 years. So you need time for not being completely rely on mm, outside partners. And of course, nowadays we are living in the COVID-19 pandemic situation, which also showed us how vulnerable can be our supply chain and how it is important to have a stable raw material supply. And for that, the European Union has created a raw material initiative, which includes a general assessment of raw materials, a criticality assessment. And the last criticality assessment, only just few weeks old, can be seen here, where a bunch of the sectors with different technologies were analyzed. And roughly 30 elements fit in the high, very high, moderate, and low risk supply um, categories, but few of them are completely 100% import dependent. So this is something the European Union needs to deal with. This is the best visualization, because this figure visualizes the economic importance, and the other axis the supply risk problems of a certain raw material. So if something is in this red area, could be problematic and closely monitored. And when they created the first list in 2014, in 2010, 14 elements were on the list, and when they got upgraded in 14, 17, and this year, this list is continuously growing, and now it's more than double, 30 are on the list. And this growing demand, because of the size of humankind and growing economy, what kind of possibilities we have for our raw material supply? Primary production, recycling, or substitution. The recycling sometimes can be really good and high level achieved, for example, platinum catalyzers, uh, and in this case, more than 95% of the platinum can be recycled, but in other elements could be problematic. For example, in indium, the recycling is around 30-35%, because we use it usually in very diluted format. Um, do you know what is ITO? Indium titanium oxide. This is a conductive material we have in every flat panels, because we need electricity for the flat screens, but how to put them to able to see through? The only transparent material uh, which can conduct electricity is the indium titanium oxide, and only few micron layers are exist in all the mobile phones, LCDs, TVs, and basically everywhere, but only few micron thin layers. And when we want to recycle, these layers must be separated and collect. So this is roughly, we are only 2/3 in indium. Or antimony, like 30 grams per 1 ton on PET bottle is used from antimony to stabilize the polymerized structure of the plastic. But the 30 grams of antimony, it's almost impossible to recycle back from the plastic bottles. So recycling cannot be an only solution, and always need some primary input. Substitution can be also a way which we are looking to use different materials, but of course it's a slow process. So it seems even in mid-term, long-term primary production we need, and how the EU looks this primary production itself. I talked about the raw material initiative, which formulates the strategy of the raw material strategy of the European Union, and it's based on 3 pillars, which is a fair and sustainable import from the global market, sustainable raw material supply from inside Europe, and of course effective resource management and recycling. Take a look closer to this second pillar. Basically, this is where the inside EU we need to improve the knowledge of raw materials with the development of innovative exploration and exploitation methods, of course, which are environmentally sound. And if we go to the action plan, implementation plan, how it is turned to reality, it is in different documents, but basically which are stated, we need to develop new exploration technologies, new automated mining technologies, and to able to utilize till uneconomic deposits like small deposits with high grade or ultra deep deposits. And of course it created exploration and exploitation project, which is funded by the European Union. It's called Horizon 2020 programs. Now it will be called as Horizon Europe for the next framework, the Framework 9, for the next 7 years. And the last 7 years in the H2020 programs, I will present here the UNEXMIN, the VAMOS, RoboMiners and CHPM project. And of course, if we talk about UNEXMIN, I must talk about its continuation, which is an EIT raw materials project, UNEXUP. These projects are environmentally sound exploration and exploitation technologies. We need a lot of remote sensing and robotization. And the main concept of them, or the general concept of them, to select them for today's lecture, is they are solutions without the need of dewatering, which is a very important environmental constraint because it creates a less social confrontation with other areas. For example, we don't need to lower the water table, so don't interfere with agriculture or the living, relaxed environment for living habitat for humans. And of course, if we know the water, we not create the acid mine drainage, we don't oxidize the pyrite and create acidic water. And of course, it's a much quicker and much cheaper solution for mining. And of course, increased robotization means less human exposure in dangerous environments, so it's increasing human safety. We need a lot of robotization, but there is a high level of robotization and automatization already existing in mining. For example, we don't go to unsafe places, but send remote excavators to dig there and control trains remotely and things like that. But these projects, they are taking the robotization and the automatization a step further than today. So let's see at first UNEXMIN.
As our life requires more and more raw materials, we have to search for new ways to find them. One of the options is to reassess old mines, and as most of them are flooded, to carry out safe and cost-effective surveys, serious technological innovations are needed. The UNEXMIN team has been set up to develop an autonomous robot solution capable of operating without remote control, as deep as 500 meters underwater. This is the UX-1, which will autonomously map the abandoned flooded mines and gather valuable geological and mineralogical information. The scientific instrumentation is developed at the University of Miskolc. The robot should be able to identify all the potentially interesting minerals under the harshest conditions. If engineers could manage to deliver all these devices to the right spots of the flooded mines, geologists could decide if it is worthwhile restarting a more detailed exploration. Researchers at the Inesktek Laboratory of Robotics and Autonomous Systems in Porto design and manufacture robots capable of self-orientation and autonomous decision-making. The UX-1 builds up a real-time 3D model of its environment by analyzing and combining flow meter, sonar, laser beam, and accelerometer information. No wonder, it looks like a spaceship from a science fiction movie. 8 propellers are mounted on the robot for propulsion. Each can work independently and in both directions. The University of Tampere is designing the mechanics. Scientists choose an abandoned quarry as a testing location. Finland is a perfect place for such a test. This time of year, the sun never goes down. The UX-1 has to prove itself in challenging sites, like Ujariça in Portugal, the Idria mercury mine in Slovenia, and Ekton mine in the United Kingdom. The deep shafts and the historical mystery make Ekton a perfect test site for the UNEXMIN project. The surface team in the control room is eagerly watching the transferred data of all types. Artificial tunnels are planned and built in an orderly fashion, but in a cave, UX-1 has to face a more irregular terrain. The Molnar János Cave, the largest underwater hydrothermal cave in Europe, lies under Budapest, the capital of Hungary. The aim of the UNEXMIN team during the test dives in Budapest is to fine-tune the navigational skills of the UX-1 in the challenging, complex environment. As the first dives of the UX-1 went fine, now is the time to shed light on murky mines.
This was about the UNEXMIN project, and now let's see its continuation, the UNEXUP, which is basically the existing technology taking closer to the market. UNEXUP is a stand for UNEXMIN Upscaling, which is an EIT-funded raw materials project, and of course, here we'd like to develop second generation of the robots, and of course a new mine mapping service, a new raw materials exploration and mine mapping service, where we can prove the technology in much closer to the market readiness level than it was earlier. Basically, the concept is to, let's see, and go back to abandoned mines if they are worth to reopen, because usually when a mine is closed, it's not closed because it's completely emptied. We are taking the last piece of mineral out of our reserve, but it's like the current economical and technological situation which is feasible to mine out. So with the advancement of technology and the growing prices of raw materials, it's worth to go back and take the remaining reserves, or even open it for a completely new reserve which was disregarded during the operation of the life of mine. So we developed the robots, and of course we proved in some challenging environments. Here you can see some nice pictures with our most challenging environment in the Acton copper mine in UK. And as I mentioned, UNEXWIN was developing the prototype and proving the concept it's working in a relevant environment. And UNEXFAB is about deployment of the technology, taking closer to the market, so create a product from the development. Here you can see our development line, evolution of our robots, the concept which was evaluated in 2015 and start building it in 16, and the first version was created in 2018, and even between the two projects we further fine-tune the technology, and our now this year will be ready in the next months. It's just under construction, but at the end of the year I can show you the videos about our upgraded version, and of course the real deep water version will come from only the next year. Of course, as I mentioned, the target is a commercial service, so to reach it we need a more versatile robot on the field, which is much more easier to operate, and not just operate but process the data, because it can deliver incredible amount of data, 1 terabyte per hour, and to use it with reduced crew needs a lot of autonomy, a lot of automation in the software controls, and this is what we are working on, to reducing the mission set on time and have a much more data collecting efficiency. And of course this data must be processed and used by geologists, because otherwise it's no use. And we need to have those software packages, those automatic processes where we can handle this incredible amount in a virtual reality environment where the geologists can interact with the data, and for example different surveys can be overlapped and see with automatic software modules what's changed in the environment. And of course our sites, we'd like to go some locations with real geological problems, with real customers who'd like to have this technology on board and able to share the cost with us. And of course the target is to build up a strong references to our spin-off company UNEXWIN Georobotics, which is created to completely exploit the technology as an offered service, not only just in the raw materials exploration market, but also in water reservoirs, cavity measurements, or cultural heritage sites, or environmental monitoring for certain hazardous situations. And of course not a whole service, but partial technological upgrades can be used in other parts. So if you'd like to see a bit more about the UNEX sub-project, UNEXWIN project, we posted a really nice video, a 26-minute video on YouTube. I really highly recommend, which gives more information. And now let's see the VAMOS project.
The project is called VAMOS. It's an acronym for Viable Alternative Mine Operating System, which really describes what it's about. It's an alternative system of mining. It's about using proven existing underwater technology and some new underwater technologies, bringing them together to create an opportunity to sustainably mine mineral reserves that aren't attractive from a conventional mining perspective.
Damen has a long history in shipbuilding and dredging in particular. And for us it's very interesting to look beyond our boundaries and look into a sector like mining. And when farmers came along, that really presented for us the right mix of opportunities with collaborating with others and exploring new technologies.
In Aztec, as the main role on the project, it was the development of the perception, navigation and awareness system on the mining vehicle. That is very important for the mining operation, and also developed this robot to support the mining operation and to build the map of the mine.
You could probably classify the opportunity into three areas. The first being abandoned mines, of which there are many, most of them flood, extension of existing mines, and there is also, I believe, application in areas where conventional mining has not taken place, even though the quality of the ore is good.
Furthermore, the VAMOS concept may also have a spin-off into other sectors. In this case, it could be also a very interesting concept for power dam maintenance.
Boskalis is well known as a dredging company and as an offshore contractor. However, our interest is broader than that. We are also interested in mining activities, and I think there is a larger potential for such a machine than only mining. There's also a very interesting control system and visualization aspects in the machine, and the electronics for measuring the material that is extracted.
So all of the preliminary work's been done, all of the design requirements and the building of prototypes have all been completed, and now we're at the stage where we're testing the complete VAMOS system.
This particular operation was closed about 10 years ago, but fundamentally the mineral still exists, and so the innovation that's working behind me is still attacking the mineral that's still in the ground. And if we could find a way of cost effectively reworking that in the future, then that's of interest to us.
Coming here to silver mines, we really wanted to test the cuttability of the machine, how much material we can process, the cutting volumes. So we're cutting a much harder rock, and that's why we've come here to this mine.
No, it's a heavy industry trial. The feedback that I've received from the local community here in silver mines has been very positive, and the overall experience has been most welcome and very enjoyable. And we look forward to maybe collaborating again at some stage in the future.
The European Union fund very different research and science projects, and they are very interested in ensuring the supply chain for critical minerals in Europe. So really the thrust of this project is to ensure that even if there are deposits of minerals in inland, in-field mines, that we're able to access those that previously and currently we are not able to access those minerals at all.
I think it will be a success once we've defined the range of operability and the types of rocks and geological environments that it can work in. So it will give us a defined sweet spot of operation, and that will be a great success.
So, about the VAMOS project. The VAMOS is targeting abandoned open pit, flooded open pit mines. And what is VAMOS stand for? It's standing for a viable alternative mine operating system. So basically a novel mining method for inland operation. And let's see how it's working. So basically, without the need of dewatering of the open pit, we create a platform with a submerged vehicle, a remotely controlled vehicle, which can mine the ore body. And this creates a lot of advantage. For example, in underwater we don't need such a high angle slope for stripping ratio, because to remove a viable ore we need to remove on the side some waste rock, and if as we digging deeper and like to remove this part, we with traditional mining methods with this gray area must be removed, and it's quite uneconomic and has a large footprint on the ground. But if we mine underwater, we can keep much steep slope angles and remove and mine only the valuable parts, and without even the watering. I mentioned the advantage of that. And also because it's working underwater, no noise, no pollution, no dust pollution and other bad effects of the technology. Here we can see the remote vehicle you are familiar from the movie, and of course it can be an easily transportable system, so much more cheaper. It can be a cheaper way than turn the mine to an underground conversion, and of course it's already creating a slurry, so don't need for crashing, and of course with a bunch of advantage on the environmental side and other from human parts. And this project, where the PAM material was tested with a underwater laser-induced breakdown spectroscopy unit to measure the chemistry if they mining ore or waste. It was such a valuable technology of this project, it went further, and it's an EIT raw materials project inside, which is focusing on these LIBS sorting system, underwater LIBS sorting system. If you'd like to learn more about the project, here you can see. Now let's see RoboMiners, which contrary to this one, it's not focusing on open pits, but more for underground mines, flooded underground mines, or even new mines.
Minerals are present in the many products we use in our everyday life, and modern societies use a large number of mineral raw materials. Public opposition to mining, alongside barriers on the access to deposits, have been limiting the extraction of minerals in Europe, despite the existence of important mineral resources. For this reason, Europe is now highly dependent on imports of many different mineral raw materials used in critical sectors such as electronics, renewable energy and defense, and conventional mining offers no solution to tackle this problem. The Horizon 2020 project, RoboMiners, is unlocking the full potential of minerals supply from domestic resources within the European Union by making mining sustainable and invisible. Wait, but how? RoboMiners is developing a bio-inspired, modular and reconfigurable robot miner for small and difficult to access deposits. The robot will be able to mine underground, underwater and in slurries. Furthermore, it will be capable of sensing the ore and excavating it selectively. Are you curious about the robot miner's final design? Join us on our journey. Check out our website and follow us on our social media channels.
So RoboMiners is a bio-inspired underground robotic miner, where we like to create a bio-inspired robot, which is roughly a 1-ton prototype. Of course, the final robots can be even larger or bigger. It depends on the technology, how it's going. but the concept is to create robotic parts where the underground mine is fully created for robots, not for humans. So a lot of infrastructure and costly infrastructure for regular mines are not needed. For example, the expensive shafts and ventilation system and other things which is needed for the humans, it's not needed here. So to have a quite large size borehole where we can send robots down there, which they self-assemble themselves, start to mine only the selectively the ore and only just the necessary sidox mined with the ore, and the slurry can be transported to the surface. But this completely new approach, not to having the traditional mine infrastructure and systems, needs a completely new strategy and mine design, and it has to be evaluated in what kind of economic system can be relevant in this type of mining method. So this is something which will not come in the next couple of years, but more in a longer term. What are the targeted mines? Are abandoned mines, where we can, after assessment of the mines, we can restart the mine even without dewatering, but completely new deposits which were unmined till now, small but high-grade deposits which were never mined due to the extensive cost of mining infrastructure, or ultra-deep deposit where was quite expensive or limited by humans to reach the in deep seated raw materials, are the main target of this type of technology. So what we are doing here is build a fully functional modular prototype and validate their key function, and evaluate the whole mining ecosystem and design it how it can be for the future. And of course I meant not in a close future, but more in a 10-30 years of vision, how can this technology help the mining. If you'd like to know more about robominers, please check on these social media platforms. And the final project I'd like to introduce you is the CHPM 2030.
Europe is facing two major challenges: the reliable access to mineral raw materials and the increasing demand for renewable energy. CHPM 2030 is an ambitious Horizon 2020 project funded by the European Commission that is working on a solution for addressing these two concerns. But how? For doing so, CHPM 2030 is developing a unique, potentially disruptive technology that will combine geothermal energy development and mineral extractions. Does this sound challenging?
CHPM 2030, it stands for Combined Heat Power and Metal Extraction. It is challenging in three ways, at least. First, it couples and combines two major challenges of Europe: the renewable energy demand and the raw material demand of Europe, Europe's exposure to critical raw materials. Secondly, it's challenging because it links together future technology of EGS, Enhanced Geothermal Systems, couples this technology with mining, which is in many people's mind it's an outdated technology. Even the terminology is for many people a nonsense. CHPM brings the two together. And in a third way, it's challenging because many of the technological elements of CHPM are novel technologies in their own discipline, and CHPM undertakes to link these technology elements into one circle of technologies.
Experts from all over Europe are joining efforts to make this novel technology possible. Their work is divided into 8 interlinked parts, known as work packages.
The aim of Work Package 1 is to provide a conceptual framework for the CHPM technology. First, the metallogenic provinces of Europe were analyzed with a focus on the mineral potential at depths and in temperature zones that are currently targets of EGS. We also reviewed 4 major ore districts in Europe, which are expectedly the test sites by 2030. The laboratory investigations on selected ore samples were also carried out, and the results were evaluated with relevancy to the CHPM technology. Finally, a methodological framework was provided which can be used as a guide for the laboratory measurements in Work Package 2 and also for the data collection for heat transport.
Work Package 2 covers laboratory experiments and ore body investigations.
The aim of Work Package 2 is to study whether networks of natural fractures that are lined with metal-rich minerals and filled with water could function as heat exchanger surfaces, and whether these could function in a novel type of engineered geothermal system designed to tap into both geothermal and ore potential at depths of 4 kilometers or more.
Work Package 3 investigates the recovery of metals and electric power generation by electrochemical methods.
The main goal of Work Package 3 is to prove the feasibility of 2 sustainable technologies. The first one is a technology that can remove metals which are very diluted in geothermal brines and transform them into materials that can eventually find a use in industry. The second technology can extract electric power from the osmotic gradient between geothermal brines and other water resources, such as brackish or fresh waters.
Work Package 4 deals with system integration.
The goal of Work Package 4 is to adapt the contemporary power plant design to the expected temperature between 120 and 190 degrees Celsius and extreme salinity conditions that will occur under the CHPM 2030 scheme. To reach this goal, experts are working on 3 main tasks. Firstly, develop the conceptual frameworks for the CHPM power plant and facility. Secondly, work on a wide range of process simulations. Thirdly, prepare the schematics and drawings.
Work Package 5 covers the integrated sustainability assessment.
Work Package 5 is ensuring that the technology developed in the project is safe for our environment and for our society. To reach this goal, the experts are carrying out 2 main tasks. Set up a framework to assess the environmental and socio-economic impacts of the CHPM technology, and carry out baseline economics for energy and mineral raw materials.
Work Package 6 is about road mapping and preparation for pilots.
In Work Package 6, the focus is on the long-term future of the CHPM technology. Therefore, the team is looking at study areas in the UK, Romania, Sweden and Portugal, where the technology could be applied, and they are also conducting horizon scanning, Delphi survey and the technology road mapping for 2030 and 2050. 2 more work packages guarantee the success of the project. Work Package 7 covers the dissemination and stakeholder involvement. It is crucial to make the findings public and reach the right stakeholders. Also, such an ambitious and complex project needs a strong coordination, and this is the role of Work Package 8 that covers project management. Now you have met part of our experts team and how they are organising their work, but what are the next steps? The CHPM is a 42-month project that started on the 1st of January 2016. In this timeline, you can see the already completed activities and the ongoing ones, the methodology framework definition, the laboratory experiments and ore body investigations, the metal recovery and electrochemical power generation, and the creation of a sustainability model framework have been already completed. 3 important tasks are still ongoing: the system integration, the integrated sustainability assessment, and the road mapping and preparations of pilots. Do you have a better picture of what the project is about now? Would you like to know more? Check out our website and follow us on Twitter, Facebook and LinkedIn.
So the last project we saw is CHPM 2030, which standing for Combined Heat, Metal and Power Extraction from Ultra Deep Bodies. So the idea is to place an enhanced geothermal system not only where the temperature is quite hot, but also where we can find ore deposits, metalliferous enrichment in quite a big depth, and to create a fracture system in that deep body, and together with the geothermal energy we can take out, and traditionally above 120 degrees we can use it for power generation, electricity generation, and later the remaining heat for geothermal heating. But here we also use the washing fluid, not just extracting the heat, but leaching out different metals from this deep body, and both on the high temperature and later on the low temperature part catch the metal from that geothermal brine before we press back the water to the ore body. And in this case we can create together different metals, and of course the electricity and other geothermal use of the heat, but of course with a lot of novel technologies, for example with the osmosis based on salt gradient, creating electrical power, which is not a high, but if we put them together can be a really nice solution to supply both the energy and the need of ores for the society. And of course I'd like to thank on the name of the different consortium of your attention. And just before I completely finish my talk, I'd like to remind you it was just the tip of the iceberg, a nice selection of robotic projects, how they can help the raw material exploration and exploitation, like UNEXMIN, UNEXUP on the exploration, or VAMOS as an existing technology for flooded open pits, or underground, completely robotic underground, flooded underground mines like robominers, or even solutions where we don't need to send robots underground like in CHPM 2030. I hope I made a nice view for you to these projects, and if you'd like to know more, search on the social media for the projects, and please, if you have any questions, don't hesitate and find me. Thank you very much, and bye bye.